Now here children, topic number 3.05, pressure. What we understand from the term pressure. This pressure topic you have studied in your lower classes in hopefully in grade 7 and in grade 8. And I want to start that the topic pressure with this very famous equation that pressure acting on a body or any surface is given by force divided by area. Pressure is given by force, force acting on any area. So if you divide force with an area, you will get how much pressure is acting on that surface. In symbolical, you can write the equation pressure force by area or force divided by area with letters. P, pressure children. Remember P, pressure is equal to force F divided by area. What area? Children here, what area this? This area is the area of contact between the two surfaces. Area of contact. For example, look at the picture on the left hand side, children. Here we have this block, and on this block, look at this vertical sign of arrow, and this is representing a force. How much? 200 Newton. 200 Newton force is acting. Where? Where, children? On the base area, that the area which is in contact with the surface. Means area of cube or this block is in contact with the surface, and they have already given that this area in contact is 2 meters square. Even sometimes if dimension is given, length is given, width is given, height is given, like breadth is given, so in that situation you can also find the area of contact. So here area is given 2 meters square, and then you need to calculate how much pressure is acting on the ground with due to this block on which a force of 200 Newton is acting. So you have to apply this equation, children. Pressure is force upon area. Force is given by 200 Newton. 200 Newton divided by area. How much is the area? 2. So 200 divided by 2, that will give you 100. So 100 what? What is the unit? What is the unit of pressure, children? Students, what is the unit of pressure?
Pascal, sir.
Yeah, Pascal is one of the unit, but I can write first. Look at this equation. Force has unit Newton. Area is given in meter, so area meter square. Newton divided by meter square, and this Newton divided by meter square is also called Pascal, PA. So 1 Pascal is equal to 1 Newton divided by meter square. So Pascal is also a SI unit of pressure, and Newton divided by meter square is also a unit of pressure. But sometimes, children, it's not necessarily that every time you will get area in meter square. Sometimes this area may be in centimeter square, in millimeter square. It may be possible. So if area, let me write it capital A, if area is in centimeter square, then what will be the unit? So in that situation, children, you can't write your final answer in Pascal. You can't write your final answer in Pascal unless and until you change centimeter or millimeter into meter square. Please note it down. Please make a note. You can't write your final answer of pressure in Pascal unless and until if you change centimeter or meter into, sorry, centimeter and millimeter into meter square. But you have a choice. If area is in centimeter square, if you want to write your answer that the some answer into Newton per centimeter square or Newton divided by millimeter square, then it is okay. Then your answer will be considered correct. Newton divided by centimeter square or Newton divided by millimeter square. It is okay, but you can't write that now the answer, if the equations or the numerical values are given in millimeter or centimeter, then unit cannot be Pascal. Pascal is a SI unit, so area should be into meter square. I hope this part is clear. Let me move ahead, children. After talking about the equation of pressure, so let us try to understand what is the relation between force and area. Means how force and area impact the pressure. So children, here there is some information is given. If 100 Newton force is spread over an area of 1 meter square, they have calculated the pressure is 100 Pascal. In the second situation, they have kept the force constant. The same force is acting where, but now they have increased the area of cross section, area of contact has been increased. Then in that situation, what is the impact on the pressure, children? You can see in the previous case when area was 1 meter square, force was 100 Newton. In the second situation, force is kept same 100 Newton, but area has been increased, means area is get doubled. So in that situation, pressure gets halved. Pressure get halved, children. Look here, it is now 50 Pascal. So from this observation, I can conclude what? That pressure is inversely or indirect proportion to area of cross section. Indirect proportion means if you increase area of cross section or area of any object, then pressure will going to be decreased. Please remember, if you make area gets halved, pressure will double. Area gets doubled, pressure gets halved. So all this information will be very useful, children, for MCQ question. Similarly, children, if you keep area constant, suppose if you make area constant, but if you increase force, then pressure will also increase, because pressure is also direct proportion to force. If you increase force, pressure will increase. If you decrease force, pressure will decrease. So all this information you have to sustain, you have to keep in your mind, children. Kilopascal, yes, sometimes it's not always that the pressure is in pascals or pressure into Newton per meter square. It may be into kilopascal, it may be into megapascal, children. So please remember that kilopascal is there. You need to convert kilopascal into pascal by multiplied by 1000. So similarly, there may be other higher values. Now, after understanding the meaning of pressure, let's look at some examples of pressure. Now, children, sometimes in our day-to-day life or in our real life situations, our life problems, sometimes we need higher pressure, sometimes we need low pressure. It depends on the situation, children. For example, I'm an athlete or I'm a player, I'm a soccer player, okay? And soccer player or the football player, they have to wear a different kind of boots, this kind of boots or shoes, in which at the lower portion we have studs. Studs, children, S-T-U-D-S. So this studs means that that very small area of these studs in contact with the ground. And if area is very less, well, then what is the impact on the pressure, children? Yon Kim, if area of contact in this boot with the ground is very, very small, then what is the impact on the pressure? Pressure will be higher or smaller? Beyond Kim.
I think it will be less.
Area is less. Area is less. Look at the equation of pressure, Yon Kim. P is equal to F upon A, and I'm saying that area is very, very low. Area of contact is very less. Then what is the impact on the pressure? It will increase or decrease? See the indirect.
It will increase.
Yeah, it will increase. So pressure will increase. So in that situation, we need higher pressure so that the athletes or the soccer players or the sprint racers, they can have a hold with the ground and they don't slip. So here in that situation, we required a lesser area, means higher pressure should be there. Yeah, I got answer from Arjun also. Thank you, Arjun, that the pressure will be higher. Good. And now another question I want to look is, look at this example, children. Uh, Here the example of knife. A person is trying to cut a vegetables. We need to cut vegetables, and to cut a vegetables, we need a very very sharp knife. It's easy for all of us to cut vegetables, to cut meat or beef easily if the knife is very very sharp. And why this sharp edge knife make to cut vegetables easily? The concept of pressure is there, children. Again, P is equal to F divided by area. Area of contact here, the sharp edge. If the edge is very sharp, then area will be very, very thin, very, very small actually. If area is the higher pressure will act on this vegetable, on the surface of the vegetables, which will help to cut the vegetables easily and easy. So that is again the concept of children pressure. Here again, I have taken the example of that higher pressure is required. But let me look at the example where we need less pressure. Yeah, Jasmine also said that because if it has a sharp edge, it has a lower surface area, and lower surface area will cause that higher pressure will act on that. Now look at this situation, children, that the third example here. Here at the construction site, if you have visited somewhere, sometimes at a construction site, suppose a building is, uh, construction work is going there, and especially at the basement, before to construct a building, we have to keep its foundation very strong. Foundation very strong means they fill this is the base or the foundation, children. The foundation is kept very wide, its area is kept very large, and on that foundation that the pillars, the bricks are put. Okay, bricks. And this area is very very large. Even in the picture you find that it's looking very small, but it's a very wide area, children. It's very wide area. And if it's wide area, and the width of this area depends upon the situations in the terms of like in Indonesia. We are here in Indonesia. That is a earthquake sensitive country. Anytime earthquake can come. And so we, to protect our buildings, that we need a very very strong foundation. So all of the buildings which we see in our areas, their foundation is very very strong, so that it can tolerate the impact of earthquake. So if the area is very large, then after that what will happen? So this bricks, or maybe the bricks, one story, second story, third story, fourth story, 15th story building, and the tallest building in the world, I think the Burj Khalifa. So in that situation, their base is kept, their foundation is kept very wide, so that the total weight of the all the stories, all the buildings above the base doesn't make the building get sink, doesn't sink. Because if area is large, look at the equation of pressure, children. If area is very 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 large, pressure will be very 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 small. So very small pressure act on that base, so that the building may not sink. So remember this point also, that the importance of sometimes higher pressure is required, sometimes low pressure is required. Another example of that we require very less pressure. Suppose I want to skate, ice skating, or if I want to walk in a snow, I want to walk in the snow. So by wearing the ordinary shoes, it's not possible. It is not possible. Means if I put my feet on the snow, I will sink. But I have to wear a special kind of boot. What kind of boot, children? Having large area of surface area, large surface area. And if I'm able to increase the surface area of my boat, then pressure will highly reduced. So if pressure is highly reduced on the snow, so it will help me to walk. uh, it will make my walk easily on the snow, and my foot or feet will not sink into the ice. So remember, children, the impact of higher area and low area will help us in increasing and decreasing the pressure. Let me move ahead, children, for some questions. So look at the example number 1. Look at this statement, children. And here in example number 1, what we have given, the wind pressure on the wall on the right is 100 Pascal. This is the wall on the right hand side, children. Wind is acting, striking on the wall. You can see here on the picture. Wall area has been given. How much is the area? 6 meters square. What is the force acting on it? What is the force? Wind is exerting a force, exerting a pressure on the wall, but how much force is acting when pressure is given and one another term, area of cross section, is given. So you can remember, let me draw a triangle, that it's a basic force here, pressure here, multiplied by this point here. You can make a partition, one more partition here. So force is given by what? Pressure into area. Remember here the sign of multiplication. Force is equal to pressure multiplied by area. So I need to calculate force. So P into A, P is given 100. What is area? Area is 6. So 100 into 6, 600, and the unit of force will be Newton, as SI unit of pressure is Pascal and SI unit of distance or area, that is meter square, is given. So unit of force will be Newton. So this is the way, children, to calculate. Sometimes children, remember, force will be given, area will be given, you need to calculate pressure. Sometimes pressure is given, area is given, you need to calculate force. Sometimes, okay, Kim, you may. And sometimes, children, uh, area is not given, but dimension is given. Dimension of the this wall is given. Suppose the length is given, breadth is given. So then you need to calculate area. And there is one question, example number 2, in which that area is not given, but dimensions are given. Let us try example number 2, children. What we have in example number 2? A concrete block has a mass. Mass is given. Now, children, remember, mass. Now, force is not given, but mass is given. And if the block measure how much? 0.5, 1, 2, these are the dimensions are given. What is the maximum pressure? Maximum pressure it can exert when resting on the ground, and you can take value of gravitational field strength G, 10 Newton per kilogram. Okay, this information is given. I need to calculate maximum pressure. Maximum pressure is possible. Let me write here P maximum. Maximum pressure is only if force is maximum and area is minimum. Area is minimum. I have given dimension, children. Length, breadth, and height. 3 values are given. So in what way I should keep this block so that the area of contact with the ground, means area of the block in contact with the ground, is minimum. Now, children, please have just take us some time. Think about this situation. What is the valid situation that you can keep this block in such a way that the area should be minimum? Any one of you, please? Jennifer?
Yes, sir.
I know the answer, that in what way you should place the block so that the area will be minimum.
According to like the diagram, it says like because it says the maximum pressure
Yeah.
resting on the ground.
Mhm.
You take one and 0.5 meter.
Yeah, actually this diagram is, suppose this diagram is not given, then children you have to think by yourself. As per the diagram it is given, if you take 1 and zero point 0.5, that will give the minimum area. If you try to place this block like this, okay, I'm just keeping in this way, so that is not the giving the minimum area, but it is giving us the maximum area. So better way, we have to keep it in this way. And when if I take zero point 0.5 and with multiplied by 1, I will get the minimum area. But if I take zero point 0.5 multiplied by 2, if I place in such a way, still it is not giving me the minimum area. And if I take 1 into 2, 1 multiplied by 2, so still it is not giving the minimum area. Minimum area is possible if I take this dimension, 0.5 and 1. So if I multiply by 1 with zero point 0.5, I will get 0.5 meters square. So that is the area. Put that value. Now children, force is not given. Mass is given. Let me erase this value for a moment, children. Uh, how will you do this question? Mass is given. Equation, you know, F, pressure is force divided by area. Force, I'm not aware about the force. Force is not given, but I know that from the chapter number 2, motion chapter, children, force is given by mass into gravity, mass into acceleration, F equal to m into g. Force is a weight. You know, force is what? Force is a weight. So I can replace this force with weight, m into g. Okay, children, force is a weight, mass is given, and now put one by one all these values. How much is mass? 2600. How much is value of g? It is given in the statement. It is given 10. What is area? We already calculated area is 0.5. And now you divide it by 0.5. Please someone do this calculation. Divided by 0.5 and check whether you are getting the same answer, 52,000.
Yes, sir, it's the same.
Same answer, okay, good. So 52,000 Pascal or 1000 you can write in terms of kilopascal also. So 52 kilopascal. Both are correct answer. Now let me do some questions from this exercise, children. Then we will move to the next topic. And I want to take question number 2. Come to the question number 2, children. I'm not doing all questions. The rest of the question you do yourself. What force is produced? Force you need to calculate, children. If pressure is there and area is given. So it's a very simple question. Force is given by P into area. How much is the pressure? They said 1000. What is the area of cross section given, children? 0.2. So 0.2 here. You multiplied 1000 with 0.2 and you will get the answer. Similarly, children, and that answer will be into Newton. You do calculation by yourself. In second B, now children, I'm on second B. A pressure of 2 kilopascal acts on an area of 0.2 meter square. Pressure is increased here, area they kept same. Now pressure is how much? 2 kilopascal. So what will be our force? Again, pressure is 2 kilopascal. Now here, children, you need to convert this kilopascal into pascal. So for that, multiplied by 1000. So this is the value of P multiplied by area. How much is the area? 0.2. So when you multiply this value, you will get your answer into Newton. Again, children, listen carefully. You need to convert kilopascal into pascal while you are finding answer for force. If you keep it 2, then your answer will be considered wrong. So it must be kilopascal should be or must be converted into pascals. Okay, rest of the question, children, please you do by yourself. All questions are very simple in this exercise. Now, children, we have another equation, another topic 3.06. And in this 3.06, this is important compared to the previous one topic. And what is this? Pressure in liquids. That was the general discussions, that pressure is given by force divided by area. But look at the situation uh, in case of a liquid. At the end of this chapter, we will come to the pressure in case of gases also. Pressures will be there in liquids, pressure will be in gases. But here, let's look at the situation, pressure in liquids. Now here, look at this picture, children. And in this image, we have a ship, a boat in water, in a river, okay? And then you can see, due to the weight of this ship, the pressure act on the on this walls here on the ground, and pressure will act everywhere actually. So the pressure is acting on these walls, on these walls, on the down, even on the right hand side also. Pressure acts equally in all directions, everywhere. Means if you try to compress an object in water, then we know due to the weight of the object, pressure will act on the walls. If I talk about on the walls of the container, pressure will act equally among all directions. That is the concept was given by the Archimedes. That is called the Pascal's law. Pascal's law, children. What is the Pascal's law? That is, it is a grade 7 and grade 8 topic, that the definition, what is Pascal's law. According to the Pascal, if you immerse, if you put some object in a water, then pressure will act on all the side of that object, or even pressure is equally distributed among all the side of the container. What I'm talking about, children, let me explain it. Now look at this diagram. On this image, actually on this picture, I have a container filled with water, and on this container, and if I just put this a very small hole here and another hole here and another, this is the cylindrical object, children. So on all the sides at the same height, if you put some hole, then what will happen? The water will come out, water will eject, okay? Water will come out from all the hole there, and one of the holes, and one of the example you can see here, children. So if you make some holes at the same position, children, on the around the circumference of that the cylinder, okay, so you will get that the water will come out from all the sides with the same speed, with the same range, with the same range of water. Means water will fall to the same position from the same, means water will fall at the same distance, children, from the same holes which are placed at the same height but at the different positions. But look at the second hole. Second hole is slightly at the middle of this container, this one I'm talking about now. At this point, you can observe that still water is coming out, but that the pressure is higher here, and due to that increase in pressure, that the jet coming out with it covered a longer distance. You see here, children, initially in the first case, the water fall at this position A, but in the second case, when the hole is at the slightly at the middle, you can see the slightly the pressure has increased and it moved, it covered a more horizontal distance as compared to the when the hole was at near to the surface. Look at the situation number third. In the situation number third, now the hole is at the bottom of the container, at the very, very bottom. And at the bottom of the container, you can see that look at the jet speed, the pressure, the water or jet is coming out with a very large speed and higher pressure is there. And that its horizontal distance, it falls slightly here at the point C. Its horizontal distance increased compared with the B and compared with the A. So then this diagram, this explains us. It's a mathematical, it's an experimental part actually, children. It's an experiment and you can try at home. And you will find that from this experiment, we can conclude In a container filled with water, pressure will be different at different positions. Listen carefully, children, what I'm talking about here. Pressure will be different at different situations or different depth in water. And so that's why here the jet is coming out, or water is coming out with a different range or different velocity at the different points on the container. Now, children, one more thing I want to discuss. We have less than 1 minute. And slightly my mouse is not working properly. So here we have different points, children, that the pressures depends. First point that you have to make a note: pressure acts in all directions. In all directions, pressure increases with depth, that we have discussed here. Pressure increases with depth. More longer you go into a water in an ocean, more and more pressure your body will experience. Pressure depends on the density of the liquid. Fresh water has different density. Sea water has different density, so the pressure will be different in sea and in river. Pressure doesn't depend on the shape of the container, children. Pressure is independent of the shape of the container. Here we have 4 different kind of objects, but pressure at the point A, B,